Welcome everybody. I brought my mask for social media and photos. Now I can take it off. That's great. It's great to see you all again. And it's been, I think, almost to the day 1 year. And I remember last year we had 50 people. Now we have 100. So if we double every year, then I think in a few years we'll be back to normal. And that's exponential growth. Last year I spoke about different technologies. And I sort of painted the picture how shipping might look in 2030, talked about robotics, AI, machine learning, even touched on quantum a little bit, and concluded that most of these technologies were already there, but sort of in different parts, maybe in different industries. And we looked at a number of startups, mostly from the EPS accelerator, and used them as examples of innovative technology. One thing to keep in mind is that technologies are still growing in not a linear fashion, but exponentially. And I think we all know better now what that means. If an Omicron doesn't increase the caseload by 1,000 a week, but by doubling every week, that is exponential growth. And so technology is still on the path, particular software-related technologies, on the path of doubling very quickly. And one thing that I think we often forget to keep in mind is, if you look just back 20 years, the kinds of different devices that actually delivered inferior user experiences, it's all sitting in what we still call a mobile phone, but it's really a supercomputer in our pocket. Another observation, which I think holds true even more so, is that innovation sometimes comes from other places. It could be adjacent industries, maybe oil and gas, maybe offshore, but it could also be from the consumer space. So it's worthwhile to sort of keep your eyes open and see what we find in other industries that we could apply to maritime. What I want to do today is sort of take stock and see, 1 year on, what has happened in some of these technologies. And I'm using some of the examples of startup companies that I'm familiar with. Disclaimer, in some of these are either EPS or I personally have some commercial interest. So I'm not endorsing them. They all have competitors. Some of them might be better than, but I'm using them as concrete examples of innovation and how that works. And some of these we looked at last year. So let's take a look at machine learning, drone robots, augmented virtual reality. But then I also want to touch on some other areas that we didn't speak much last year about. And those are simulation and quantum computing related use cases, as well as some of the non-digital technologies that matter. So here is one company called NAUTILUS Lab that uses sensor information from the vessels and does performance optimization, uses weather information, lots of other information sources, and uses that to optimize voyage and generators and performance and so forth. And it has delivered real savings. And 1 year on, they work with many more fleets now. Initially it was mostly, I think, Eastern Pacific. And you see, how many metric tons of emissions and of fuel they deliver. So those are real savings that we found. But that's actually only part of the story. Almost more interesting, and this is something that I think Nautilus just started doing recently, is normally in a time charter agreement, it's the charterer's problem to deal with fuel consumption, not really the owner or manager. And that might lead to suboptimal situations, because it might be the owner that has the technology but doesn't have any commercial interest. So Nautilus Labs started working with their customers and their customers' customers, and use the technology, and being sort of a trusted third party in the middle, use this technology to make this information available to the charterers and overall achieve higher emission reduction, which of course helps the owner as well with the CII index improvements. So that's something really exciting. I think later we talk about collaboration and working together across maybe different commercial incentive structures. So that's been really interesting. Another one we looked at briefly last year was Captain's Eye, which is using just standard cameras on a vessel to detect, and then behind that, of course, there is artificial intelligence and machine learning models, to detect situations that can be dangerous for seafarers. So if people don't wear their PPE, if they're in a wrong area at the wrong time and doing mooring operations, but also they added on smoke detections and various other things. And so this is just an example here. If smoke gets detected here, then immediately, of course, people would get an alert and could act with it. And it's just using standard cameras, so nobody needs to watch any cameras anymore. And the interesting thing, because it's neural networks, machine learning, is the more data, the more experience they have with this kind of thing, the better the results get. This is just sort of inherent characteristic of machine learning. Another example is, Dead Man's Alert here. And what's still remarkable for me every time I watch this thing, it's a very cluttered, visually very cluttered environment. So even as a human, I think if you would be watching this, you probably would miss the interesting events. And of course, the system here only detects when something happens and then alerts people, and then they can act with it. So that's one interesting aspect. But what they have added over the year was dashboards. So you have the alerts, you have the warning systems and all that. But then once you aggregate all this information, then you can start doing a comparison within a ship and then, of course, across the fleet. And eventually, probably not just across your own fleet, but comparison against others. And then you can do things like, how come this crew and this captain has better results given otherwise similar situations? Who is more complaint-minority, sort of gamification, leaderboards. You can then really do, and you can use it for training. So this dashboard functionality for individual ships, but also across the fleet and across time. That turned out to be really popular and really powerful. And it's almost like you hadn't really thought about these potential applications. You're adding on both new cases and new application areas with this kind of technology. And keep in mind, it's basically just software. The cameras are just standard, cheap cameras. It's the software behind that runs on a server, on a normal sort of high-end PC on the vessel. So that's really interesting. And by the way, this is also something that has been used for many years onshore, but it's still, as far as I can see, one of the early companies that uses this on vessels, probably because people didn't have cameras on board and just nobody thought about that. So they made really good progress. Then drones. So F-Drones is a company that, again, is part of the Accelerator, Singaporean company. When we met them last year, they had done the first shore-to-ship deliveries, and that was good, but they still used a standard commercial drone. What they've done last year is they had their own proprietary drone, and they start doing commercial deliveries over 15 to 30 kilometers. And these things fly fully autonomous. You don't need a pilot anymore. And it's not just the technical capability. It's also getting the permits from somebody like Civil Aviation Authority, MPA, and so forth. What they're doing now, it's this is, actually let me show it to you. This is something that will run over 50 kilometers. They just had the first trials here in Singapore. And I was there with my trusted iPhone. So this is a hybrid drone. You might remember, recognize where this is. This is the South Marina Drone Estate. And so it uses a helicopter mode with, the rotors to take off, and then it swivels into a fixed plane mode, which of course is much more efficient. And it's using the same set of propellers for that. And again, it's actually the beauty is in the software. So a few hundred times a second, it determines the status of the aircraft, the environmental conditions, what it's supposed to do, because it's flying, again, fully autonomous. And then it switches back to the VTOL, the vertical takeoff and landing mode, to land. And it's because it's using the same propellers. It's called zero dead weight propulsion. You don't have any wasted weight on board. And yeah, that's me watching that. So that's one example. Another example is robots. And because the technology is getting, in general, sensors and IMUs and sonar and all these things that you need to make that happen, now you can have robots. Elisha Bots is one example here. That is so inexpensive that you can probably afford to put it on a vessel. This is like Bill Gates' vision of having one computer in every household. Now you could have, if you want, one robot on every ship. And it's autonomous, and it can be used, it's lightweight, so it can be used by the crew for visual inspections, if you need to see if something is serious or not, and for hull grooming. And that means you can actually do things differently. If you have a robot like this on board that can more frequently groom and clean the hull, then you might need less sort of big, expensive diver-driven hull cleaning operations. So that's another example of just over 1 year we have seen tremendous progress. A year ago these guys didn't have anything to show, and now it's in operation. And another one is virtual reality. We talked about Kanda last year, and I think virtual reality is really becoming reality. And this is the only one of the few things where the virus really helped a little bit, because now it was no longer optional to use virtual reality for training, but it's almost a no-brainer. And these guys have gotten tremendous traction actually in the offshore wind industry, where they have tens of thousands of engineers that need to be trained using virtual reality. So those are some of the companies and technologies that we looked at last year. And in general, we've seen some great progress, both within the companies, their customers, but also driven by the technology. Now let's take a look at where the technology is going. And the first one I want to take a look is virtual reality and augmented reality. So here we see devices that are coming to the market now and this year. And these are virtual reality / augmented reality. They will still cost a few $1,000s, but what is a few $1,000s today is a few $100s tomorrow. And what's interesting here is obviously tremendous increase in pure capability. So from 4K that you might know from a consumer space per eye, you're going not just to 8K, but to 12K. But that's, what does this really mean? The interesting thing is it reaches the human perception. So if you can no longer see pixels, then, you're there. It doesn't matter. That means for the user, you can no longer distinguish between what is, fake reality and what is real reality because you can no longer see pixelation. And that's what the 12K really means. The other thing is that these devices have, I think, 11 or 12 cameras. What do they track? They track your arm movement, your body movement, your lips, and your eyes. And as you probably know, if you can only see something sharp that you're directly looking at. The rest is blurred anyway. So now this device measures where you're looking at, a few hundred times per second, and then only renders in real time that stuff sharp that you're looking at. So you're using this computation capability in, really smart ways that I wouldn't have thought about. And the other interesting aspect here is the field of view. The human eye the brain has 200 degrees of field of view horizontally. If the devices now reach, or 220, if you reach 200, then you're almost there again. You're reaching the threshold of human perception and capabilities, and then that's good enough. And that's really what's happening this year. And one missing element you might think in industrial and shipping training is, the muscle memory. You're touching things, you're moving things, how about that? That is certainly one of the weak links. Well, let's take a look at what's happening there.
Actually at. So let's start with the Tesla glove. This is the first time I got to see this glove in person, and it's actually nuts. Featuring a full exoskeleton with haptic and force feedback, but there weren't any demos available to try with them, just the opportunity to try them on, which just looking at them is kind of cool on its own. However, in terms of actual demos, next were the Sense gloves, a simpler force feedback glove that hold back the position of 3 fingers and your thumb. In the demo, I built a robot in virtual reality holding a drill, feeling the trigger of the drill as I pressed the trigger of a virtual drill that didn't exist. Really an awesome experience, and it relied on an actual controller for the tracking rather than hand tracking, so it was relatively accurate as well. Next up, the Contact CI gloves, a full hand haptic and force feedback glove that specifically has super accurate fingertip haptics, allowing you to feel really light sensations like flicking the switch in an airplane cockpit and holding back your fingers when gripping an airplane yoke. These by far were the most immersive gloves that I had tried and made me feel like I was actually in an airplane cockpit flicking switches and pressing buttons. But all of these options are very expensive and really only enterprise focused, unlike the bHaptics haptic glove. Using Quest 2 hand tracking and small accurate fingertip haptic motors, you can feel things you touch in VR. And these are the ones I could find myself actually using really often. And coincidentally, they're the only ones that are shipping this year to consumers for $300, a fraction of the $5,000 or more asked for these other gloves. Via and I were able.
So this is really fascinating, right? Because we can say you can feel the switch and the resistance. That's, I think, super helpful. It's sort of the last missing bit of virtual reality experience. So that's what's happening, I think, in virtual reality. This, by the way, was taken at the Consumer Entertainment Show in Las Vegas in just this month, actually. So this stuff is developing very, very fast, obviously, from a consumer perspective. If you're saying this is only for enterprise, well, we are enterprise, so we can use it first. But it's also interesting because this is purely coming from a gaming world. And so gaming actually has driven a lot of innovation, particularly in this sector. Now let's look at some of the computational methods that this is a little bit further out, but personally I think this would have an impact. So I found this company at the Space Accelerator in Singapore, where I'm mentoring some companies, and they're called EMTD Lab. What they use is initially for material that does space radiation shielding for astronauts and computing equipment, but it has lots of terrestrial applications. They're using computational simulation methods to discover new material, advanced material that has certain characteristics. And that's much needed in many areas. And I think this can also have an impact on new material you might need for hydrogen storage or for hull coating or for ship design itself. So the fact that you can run something on supercomputers and you discover new things that you didn't know existed or couldn't explore. By the way, this is very similar to what drug companies, pharma companies do. So this is sort of already being used in drug development. But some of these models run, I think, weeks on end on a supercomputer. And this is where quantum computing could come in. So quantum computing, what runs, actually is even impossible to run it because it would need tens of thousands of years of computational time. You can run in a few minutes on a quantum computer. Now they're still developing, but developing pretty fast. So recently a McKinsey report came out that concludes that between 2025 and 2030, we will see fully fault-tolerant quantum computers. And in the meantime, we can already use them in various ways. And again, this is something where tremendous investment, you see this exponential growth thing that reminds us of the Omicron thing. Can't think of anything else. That billions of dollars going from private investors into these companies. And actually Singapore is pretty strong. So it's the Center for Quantum Technology in Singapore with a whole bunch of commercial spin-offs. So this is probably one of the 10 most interesting places in the world. And then you see the public investment, not surprisingly, or maybe surprisingly, China and the EU investing a lot. And it's great to see Singapore definitely punching above its weight there. And so there's tremendous investment going in. The shortage, actually, I think, is the skill. You have only, still very limited number of quantum physicists that you need to build that stuff and engineers. But this has, really promising potential, I think, is coming relatively soon. So these are some of the early use cases that people see in other industries, pharmaceuticals, finance, and so forth, but also in maritime. As usually, maritime is sort of maybe a late adopter of these things. So this is sort of simulation methods and computational methods that I think will have an impact. And they also look beautiful, these quantum computers, don't they? Let's look at, not everything is digital. So there are also some really interesting technologies, and I just picked a few. This is just my personal view, by the way, not Eastern Pacific's, that I thought would be interesting. So one is a Canadian company called GIT. They're actually testing, as part of the accelerator, they're testing their coating currently with EPS. And they develop a coating that will reduce biofouling, non-toxic, and it will reduce drag and fuel consumption. Hopefully, that's the idea, but we're testing that. So that's really something where eventually it could probably be impacted by quantum computing to discover new solutions, but right now this is really sort of a non-digital technology. And another one is as part of the future fuel supply chain. People talk about hydrogen, and even more so, can we use ammonia generated from hydrogen, potentially? And this is a company that is using bio-waste, so agricultural waste, municipal waste. They have announced a whole bunch of projects in Australia, and they're looking into other countries now. So they're taking bio-waste or waste in general, producing green hydrogen from that, which then could be used to produce green ammonia. But they also create a whole bunch of byproducts, like biochar, so they're actually carbon negative. So they can, as a business model, it's interesting because they produce what we all want, but they do it in a form that actually takes out carbon, and they get credits for that. So that's an example that, again, there's very little digital about this, but nevertheless really interesting. And then finally, if you have, according to my friends from Core Power here, the largest 20% generate 80% of the emissions. And if you think about a 22,000 TEU container ship, how much fuel does that need over its lifetime? And if you take, the 16, the slow steaming, 90 tons of heavy fuel oil per day, and it's much more if you go higher, according to my math, this is at least 1 million tons of heavy fuel oil over the lifespan of the ship, never mind all the infrastructure to create it and so forth, and of course, tremendous emissions. If you had a nuclear reactor that would be the small green thing on a container ship, you would need no refueling. You could be at a much higher speed for the entire lifetime of the ship. And it's probably worth thinking about it if that's true. Now, how much spent fuel do you think you would have from 30 years at higher speed? It fits into a washing machine. That sort of demonstrates the tremendous difference in energy density of this type of fuel. Now, I know there's a lot of debate around factors, but it sounds to me it's maybe worth thinking about. So those are some of the thoughts around technology. I'm very optimistic about digital technologies. What we're seeing, the innovation still, I think, comes largely through small companies. So it's worth for all of us to keep engaging with these companies, be patient because nothing works the first time in those things, and sometimes people don't understand the industry as well. But it's definitely worth, from what I can see, continue to engage with small innovative companies and also think, a little bit bolder perhaps. That's what I wanted to share. Are there questions? Let me just say the last thing here, that we do have a fantastic day ahead of us with topics like policy and leadership, investments, because you need money to make these things happen, how to reduce friction in global trade, decarbonization, of course, is the overarching theme, and collaboration and connecting different parties. With that, thank you very much. And what questions do we have from the audience or online?
Thank you. Klaus, fantastic introduction there and great run through of some of the new technologies coming through at the moment. If you yourself were to pick one of these to invest in with your own money, where would you go? I mean, what would be the one that most excites you and you think has the greatest potential out of the list that you had?
It's an interesting question. I would think, but it's a little bit personal bias because I did some of the stuff before, would be virtual reality and augmented reality. Why? Because I think there is a tremendous opportunity to really change the way that training and development is done, and it addresses sort of the most important element, the humans running these big machines.
And do you have personal virtual reality stuff like the Oculus headset yourself at home?
Yeah, I used to have one, but I think I'm waiting for the Apple Glass, which people say will do amazing things.
Go. Thank you.
Klaus, we have a question for you from the virtual audience. Gagan Mishra has asked, is digitalisation more effective when we talk about monitoring effects of decarbonisation?
Yes, I would think you need to measure before you can do things. And I think digitalization in the first step, the IoT systems like the Nautilus are a good example. Once you can measure things, then you can compare, you can benchmark, and then you have concrete ideas, what's the root cause, why something works better than others, and then you can go after that and improve that.
Okay, thank you. There's another question here from the virtual audience. Come on, physical audience. The virtual audience are beating you, so you better get your questions ready. So from the virtual audience, Juliana Inash has asked, we all know that accelerating digitalisation make businesses susceptible to cyber attacks. Do you know if the digital solutions mentioned in your presentation are also tested in order to be safe from a cybersecurity point of view?
That's an excellent question, and I didn't talk much about this. I think the answer overall is yes. And, at EPS, we pay tremendous attention and, work with other startups like CyberOwl to protect ourselves against it. But I think it's something thanks for the question, I think it's something to continue to be aware of that, because often the companies that focus on all of these things, it might not be foremost in their mind. So I think that's something actually that behooves the owners and the early users to point that out before you roll this out in production, making sure that you have an audit done and that, it's properly protected. That's a very good point.